Hello, everyone. Good afternoon. I hope I'm audible and visible. Respected authors and invited guests, welcome to the technical session 6E. Myself, Gayatri Bhurguda, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2026, Pune, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is being held today in Pune, India, and the virtual event is being held through Zoom from 19 to 21st January 2026. I hope you all will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for questions and answers. For 9 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any kind of query or update, then you can add it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session. Um Professor Dr. Vinodrek Tumar is working as an assistant professor in Vishwakarma Government Engineering College at Ahmedabad, Gujarat. He has more than 14 years of experience in industry as well as academics. His research areas are data security, blockchain technology, and AI. He is also involved with an expert team of professionals working in RPA, ML, and AI. Sir, would you like to address the participants?
Uh, yes, I would like to wish all the participants for a better performance in the presentation, and we will proceed as because of the time constraint, so you can proceed.
Yeah, okay. Thank you so much, sir. I would like to start with the presentations. Moving on to the first presenter of today, Mr. Likitapudi Pavan Raj Kamal, to present his paper titled A Distributed Agentic Model for Enterprise Workflow Coordination. Over to you.
Good afternoon.
Uh, yeah, you can start sharing your screen and you can start presenting.
Good afternoon, everyone. The team, the title of our work is a distributed agentic model for enterprise workflow coordination, and I am the presenter. The problem statement is the basically the traditional HR teams do the tasks manually, which takes more time. They have to handle all the errors manually and check up all the tasks for freshers, interns, and every employee. So this manual time-taking process can be more dependent on heavily on manual interventions, which can lead to time delays and inconsistency. So moving on to so the research gap and objectives. The research gap, what we identified in this by this project is basically manual HR systems heavily depend on manual interventions. So even though the automation has emerged, like query chatbots, which just answer the queries, I mean employee queries or intern queries, but do not do that task actually. So focusing on just recruitment or just onboarding, the real gap we identified is One minute. My screen is stuck. The real gap we identified is this. There is no comprehension solution that we can orchestrate workflows across different departments while maintaining accountability. Organizations need systems that work seamlessly across HR, IT, and finance, but current solutions simply don't address this cross-functional coordination challenge. The research objective is to address this gap. Our objective is to design a distributed agentic HR framework that can understand intent of the employee or an intern, interpreting employee queries beyond just keywords. Second is reason using organizational knowledge, like from using a RAG based system, retrieving the information from the knowledge policy provided by the company. Third is execute workflows autonomously, completing multi-step processing without constant human intervention. By using the agentic AI and tools like N8N and RAG-based systems, we can uh, automate the workflows, and that can be done without constant human intervention. And fourth is maintain human oversight, ensuring critical decisions still require human approval for accountability. Like for sensitive tasks, we require human in the loop and traceability uh, solutions. So we can also implement. The core novelty of our work is agentic HR paradigm instead of reactive automation, event driven multi agent architecture, agentic RAG for retrieval, reasoning, and action, workflow orchestration across HR onboarding, human in the loop for high risk decision. And the key contributions are conceptualization of agentic AI in HRM, modular, scalable system architecture, empirical evaluation across autonomy stages. The system architecture we proposed is this. So it basically comprises with five agents: orchestrator, provisioning, scheduler, liaison, and guide agent. So orchestrator agent is the main agent which monitors all the four remaining agents. Provisioning agent creates tickets and accounts for IT ticketing system and HR and retrieves the information from HRS database. Scheduler agent uh, arranges the meetings for interns and employees automatically. Liaison agent takes the tasks from the orchestrator agent and delegates them to the new hires with the constant communication. And guide agent is like a personal agent for every employee and intern, where employee or intern can ask any questions and actually make the agent do the task. Like for applying for a holiday, it doesn't just answer that you just have some remaining holidays. It actually applies for the holidays without involving the task to do it manually. The major components are guide agent, workflow orchestration agent, onboarding and scheduling agent, and security layer. Security in this architecture is role-based access, encryption, and audit logs. Methodology and workflow execution. How the system operates is user queries or ordination event occurs. When the ordination event occurs, guide agent retrieves the policy context from via vector search. from the policy provider. Autonomous reasoning determines next action. Workflow agents execute tasks or escalate if required. System evolution, we compared by three stages. Stage one is conversational RAG, which is just a basic RAG with no tools provided. Stage two is agentic RAG with tools. And stage three is production scale multi-tenant setup. Evaluation and results. Metrics we use are retrieval accuracy, context precision, faithfulness, that is hallucination control, response latency, and automation capability. And the key results are accuracy improved from 62 to 87%, faithfulness improved by over 25%. Although latency was a bit high because of the tools we used. Significant reduction in HR manual workload. Latency increase justified by automation because we used automation tools. Responsibility, security, and limitations. Accountability and risk handling. Policy grounded responses via RAG. Human approval for sensitive actions, full audit trials for agent decisions, clear separation of agent autonomy and authority. And the limitations are prototype staged deployment depends on quality of HR policy documents provided. Predefined workflows limit emergent behavior, higher infrastructure cost at scale. Coming to the conclusion, agentic HR enables intelligent workflow automation. It bridges the gap between the chatbots and the enterprise execution, improves efficiency, consistency, and user experience, and is scalable and compliance aware by design. And the future work is of predictive workforce analytics, like predicting the hiring trends and the user experience.
Hello, sir.
Employee.
Your time is up, so can you please speed up your presentation?
Yeah, sure.
No, thank you.
Yeah. And second is adaptive legal compliance. Uh, Dynamically, every company uh, changes their policy by timeline. So, adaptiveness to the legal compliance and the rules by the company. ERP and CRM integration and fairness, DEI auditing, which is diversity, equity, and inclusion. Thank you for the opportunity.
Sir, do you have any questions?
Yes, I would like to ask one question that you have mentioned accuracy. You have
Yes.
mentioned that you have improved from 62% to 87%. So, will you tell me how you have measured this percentage?
The accuracy, sir.
Yes, how you have
Um,
measured this accuracy? On the which data? On the basis of which data you have measured this accuracy?
yes, sir. I'll show. Am I
Mentioned
audible?
in the
Sir,
yes, you have mentioned that data in the table, but how you have calculated this value?
sir, we developed three prototypes by ourselves. Like stage one, just a normal chatbot, and stage two, the agentic RAG with tools, and stage three, the agentic automatic RAG. So we compared the accuracy of the results that it provided. So we sent multiple queries to the chatbots to each chatbot, and around 10 queries for each chatbot. and based on the responses it gave, and based on the all the results it gave, and a task it implemented, we measure the accuracy using that data
Okay, it's
by
fine.
the results it provided, like the response it provided and the task it implemented, whether it's actually doing the task or not. So based on that results and responses, we measured these by these metrics.
Okay, next presentation, please.
Yes, sir. Thank you for your presentation. Now I'd like to call upon the next presenter, Yogita Seth, ma'am, to present her paper titled A Soft Voting Ensemble Approach for Accurate and Reliable Sentiment Analysis. Over to you, ma'am.
Yes, good afternoon, everyone.
Good afternoon, ma'am. You can share your screen and start presenting.
Yes, ma'am. Whether my screen is visible?
It's visible, yeah.
Okay. Good afternoon, everyone. My paper ID is 781. My topic is Soft Voting Ensemble Approach for Accurate and Reliable Sentiment Analysis. I am a research scholar from Vishwakarma University, Pune, Computer IT Department. So this is the agenda for today. Introduction followed by literature survey, problem identification, objective of my topic, proposed methodologies, conclusion and references. So in recent years, there has been an enormous increase in user data that has textual data on social media and e-commerce platform. Organizations rely on this data to understand public opinion and customer satisfaction. So we need to analyze our noise, imbalance, and sentiment analysis is done on that. Traditionally, the sentiment analysis was done by uh, Lexon based or handcrafted features. These approach have some limitations. So these limitations were overcome. We need to overcome that limitations. The limitations were related to linguistic, context dependency, scarcity, or ambiguity in real world. So the main concern was to overcome these challenges. So my the main contribution of my paper is to investigate the ensemble-based sentiment analysis model that will integrate multiple ML classifications for performance and stability to evaluate the performance on model using both traditional and reliability oriented metrics, data detail class wise description, and to balance my data set for the classification. So this is the literature survey which I have done for I have observed with the previous studies for machine learning, deep learning, and transformer models. While these models achieve good accuracy, many suffer from limitations such as language dependency. Overall database means sometimes the data set is small. For that data set, there is the class is imbalance and high computational cost. So these gaps motivated me to need for this robust ensemble based approach. So my problem identification is sentiment analysis on real world is a challenge due to noise, imbalance and contextual ambiguity. So since the sentiment single classifiers, for example, suppose we are dealing with any single model, say single classifier often provide inconsistent and unreliable predictions. So most studies focus on accuracy but ignore the probability. Hence, there is a whenever we are dealing with combination of the models or ensemble, then we can get high accuracy and reliable confidence for that particular estimate. So my objective is to develop a reliable ensemble-based sentiment analysis model. The aim is to improve the classification performance, handle class imbalance, and provide well-calibrated predictions. So this is my proposed methodology. So I have taken the database from Amazon product customer rating. So this here, the database that is contained is having a unstructured as well as structural data. Structural metadata such as for reliever and user identification, and unstructured textual data representing the customer's opinion. Each record corresponds to single customer. Then total there are 10261 reviews. In that, some are positive, some are negative, and some are neutral. But whenever we are dealing with this, first we need to pre-process that particular data. Pre-processing means that we will be removing the we'll be cleaning the text data, such as by lower casing. We will remove the punctuations, we'll remove the noise, we'll remove stop words removal, and lemonization. Means, for example, we are suppose there are any stop words, suppose there are any is, are, and that words which are not required for sentiments, or suppose my running is there, didn't require running, I'll require run. So to eliminate that, everything will be pre-processed in this thing. After that, we will go for feature engineering. In feature engineering, we'll use TF IDF bigraph to capture the contextual relationship and sentiments patterns. So in this, whatever word or word pairs are there will be identified using that. We'll create a vocabulary for that. And vocabulary is limited to I have limited the vocabulary to 5,000 words. The result is efficient and a sentiment. After that, I'll take a SMART. SMART is what? SMART is this analysis technique is used to balance the data set. Suppose there are three types of text commands, that is positive, negative, and neutral. So suppose the data is imbalanced, means for example, positive data is positive comments will be, suppose example, if there are positive comments are higher, negative comments are lower, and neutral comments are all much lower, then the SMART technique will balance the data set. SMART is synthetic minority over sampling text. Means what? Whenever the data set for the particular classification is less, SMART will generate automatically minority classes samples instead of duplicating that samples. It works with the nearest neighbor for that particular feature space. So after that, whenever we'll do this SMART, means what? After the SMART, all the data set will be equal. Means every sentiment for positive, negative, and neutral all will be having a balanced data. Whenever we are dealing with balanced data, if we are not dealing with balanced data, then the performance will be biased towards the majority class. So for that, we need to balance our data set. Next is whenever we are dealing with this ensemble, means what? It will then we'll split the data, and for 80% for training and 20% for testing. Ensemble model means we have used a soft voting ensemble strategy. Means what? Multiple classifiers generate the probabilities, and that probabilities will be get combined to produce a particular sentiment that will be labeled either as a positive, negative, or neutral. So this improves robustness and stability for that particular single classifier. So this is my proposed methodology. Now, how this SMART worked in my data set. See, these green bars indicates the balanced data set. But before that, the data was 9022 was there for positive, 722 was for neutral, and negative was 461. So whenever after the SMART technique, I have, with the help of SMART technique, I have balanced this data set. So you will see the green graph that are balanced the data set for 9022. So each and every classifier will be having 9022 for each. Then data pre-processing, we have done data pre-processing, that is for cleaning and that purpose. So this is the Ensemble model means what? In this proposed approach of soft voting based ensemble strategies adopted, where selected base classifier generate a class probability estimates that are subsequently fused with determine final sentiments. Means sentiment analysis dataset is there. Will combine this with all different machine learning algorithms and we'll get a prediction, and that one prediction will get will take average of that prediction and will detect whether it is positive, negative, or neutral. So this is the performance analysis of ML and ensemble model.
Excuse me, ma'am.
Yes.
Ma'am, you have reached the 9 minutes mark. So can you
Okay.
please speed up your presentation?
Yes, ma'am. Yes, ma'am. Yes.
Thank you, ma'am.
Yes, thank you. This is the confusion matrix for my ensemble model. So confusion matrix shows that the ensemble model performs exactly with perfect classification for 0. For 0, there are no misclassification. So positive classes are identified 2255. There are no misclassification. There are high accuracy for class 1 because there are misclassification of 68 and 3 is there, and low and relatively higher misclassification for class 2 because class 2 are having 155 and 276 as a misclassification. So these are the results. So this is the class wise curve. Class 0 will be having accuracy, more accuracy than class 1 than class 2. Okay. Conclusion, this proposed ensemble model effectively address noise, imbalance, and uncertainty. It achieves higher accuracy and better probability calibration. My future work will be integrating transformer embeddings, weightage voting, and the deep learning algorithms and access the multilingual access to this process. Thank you. Any questions?
No questions. We can move forward.
Okay. Thank you, ma'am, for presenting. Now
Ma'am, can I
I'd
leave?
yes, ma'am, you can leave.
Any processing is left? No, no.
No, ma'am. You'll get your certificate in 2 days on email.
Okay, ma'am. Thank you so much. Yes, have a nice day.
Thank you. Thank you. Now I'd like to call upon our next presenter, Shantanu Pradhan sir, to present his paper titled A Study of Deep Learning Approaches for Automated Plant Disease Detection. Over to you, sir.
Hello. Good morning, everyone. Am I audible?
Yes, you're audible.
Is my screen is visible?
So your screen is visible. You can start
Okay.
presenting.
Good morning, everyone. My name is Shantanu Pradhan. I am pursuing BTech in Computer Science and Engineering, third year student at SRM Institute of Science and Technology. I will be presenting our work titled A Study of Deep Learning Approaches for Automated Plant Disease Detection. This work focuses on evaluating modern deep learning models, specifically YOLO V5 and YOLO V8, for plant disease classification using a standardized experimental setup. So, plant disease significantly reduce crop productivity and pose a serious threat to global food security. And it founds our problem statement. And in early and accurate disease detection is therefore extremely important. So, traditional and manual inspection methods are time consuming and subjective and prone to human error. So these limitations make them unsuitable for large scale agricultural monitoring. So this motivates us the need for an automated reliable and scalable AI-based solution that can detect plant diseases accurately and efficiently. So our study addresses this need using deep learning based classification models. So moving forward to that, why we use deep learning and YOLO. So deep learning models, especially convolutional neural networks, are highly effective at extracting complex visual features from plant leaf images. And YOLO models are particularly attractive because they provide end-to-end processing with real-time performance. So they combine speed and accuracy, making them suitable for deployment in practical agricultural environments where fast decision making is required. So that is why we selected YOLO based architectures for our study. Coming to the objectives of the study. So the main objective of our study is to compare the performance of YOLO V5 and YOLO V8 for plant disease classification. So to ensure fairness, both models were trained and evaluated under strictly identical experimental conditions. And the comparison is based on key metrics such as accuracy, validation loss, and training time, allowing us to access both effectiveness and efficiency. Coming on the data set description, so we have fetched the data set from Kaggle and used the Plant Village open source data set, which is widely used in plant disease research. And the dataset contains 15 distinct classes, including both healthy and diseased plant leaves. And these classes contains around 20K images of both healthy and uh, diseased plant leaves. And the data was split into 80% for training and 20% for validation. And all images were resized to 224 into 224 pixels to maintain consistency across experiments. Now, giving the description about our experimental setup. So all experiments were conducted on Google Colab using NVIDIA Tesla T4 GPU. And the implementation was done using the PyTorch framework and the Ultralytics YOLO API. Both models were trained for 10 epochs with a batch size of 16, ensuring a controlled and reproducible experimental setups. So the models used in our studies are explained in this slide. So for YOLO V5 classification, we use the Adam optimizer and focusing on faster training and lower computational overhead. And for YOLO V8 classification, we use the Adam W optimizer, which is designed to improve convergence, stability, and generalization. So this step allow us to observe architectural and optimization differences between the two models, and uh, to show which model is more robust and reliable between these two. So coming to evaluation metrics, so we evaluated both models using four key metrics. The first one is top one accuracy, which measures how often the model's top prediction matches the correct class. And top five accuracy checks whether the correct class appears within the model's top five predictions, giving insight into prediction confidence. And validation loss indicates how well the model generalizes to unseen data. And lower loss means better generalization, and higher loss means there is overfitting in our training. So finally, training time measures computational efficiency and resource usage. So here is the performance comparison between the two models, that is YOLO V5 and YOLO V8. The performance comparison shows that both YOLO V5 and YOLO V8 achieved near perfect accuracy. And YOLO V5 achieved 99.7% top 1 accuracy, while YOLO V8 achieved 99.6%. Uh, so the accuracy difference is marginal, and YOLO V8 recorded a significantly lower validation loss, indicating a smoother and more stable convergence than the YOLO V5 model. So, coming on key results and observations. From the results, we observe that both models are highly effective for plant disease classification, and YOLO V8 shows better convergence, stability, and generalization because it is having less validation loss than YOLO V5 model, and YOLO V5 trains faster and requires less computational overhead because the architecture that is used it is simpler than used in YOLO V8, that is Adam optimizer, and this highlights a trade-off between training efficiency and convergence stability. So, coming to the conclusion, this study demonstrates that YOLO-based deep learning frameworks are highly suitable for plant disease classification, while YOLO V8 offers stronger generalization and smoother convergence. YOLO V5 provides faster training with minimal resource requirements. Overall, the results confirm that deep learning provides an efficient, scalable, and reliable solution for automated plant disease detection in real world agricultural applications. So, thank you for your time and attention. I will be happy to answer any questions.
No questions from my side.
Okay, sir.
Thank you for presenting. Now I would like you can stop sharing the screen,
Okay.
and now I would
Thank
like
you,
to
ma'am.
call upon our next presenter, Meet Shah sir, to present his paper titled "Advancing Decision Making in Cricket: A Review of AI-Driven Decision Review System." Over to you.
Yes. So, good afternoon, everyone. My name is Meet Shah. I am from MIT World Peace University, Pune. The title for my paper is Advancing Decision Making in Cricket, a review of AI-driven decision review system, which is known as DRS also. This is the table of content I'm going to follow throughout the presentation. Introduction, motivation, and problem statement. So, basically, cricket requires extremely precise and time-sensitive decision. A single incorrect decision can impact match outcomes and fairness. Modern cricket has increased speed, pressure, and complexity, but it still lacks various things. Human umpires face fatigue, pressure, and visual limitations. Subjectivity and inconsistency can still affect critical decision. With respect to that, I have considered to take few of the event classes. This is a traditional decision review system in which technologies are used currently, like Hawkeye for ball trajectory tracking, Ultra Edge for audio-based edge detection, Hotspot for infrared contact detection. This also carries limitations such as calibration errors, noise and lighting sensitivity, subjective third umpire interpretation. What is the role of artificial intelligence in cricket? So AI basically enables automated and data-driven decision. It processes the visual and temporal information. It reduces human bias and improves consistency. Acts as a decision support, but not as a replacement. Literature review for how many papers have been done. So we can even use classical machine learning models such as SVM and random forest. SVM can be majorly used for LBW, no ball, and binary decision accuracy with approx 85 to 95, but depends on the handcrafted features on how a bowler or a specific batsman works. Random forest, which is robust to noise, used for gesture and boundary detection accuracy, basically for 6 and 4. Deep learning models, convolution neural network, it is a visual feature extraction for no ball boundary and umpire recognition, which can be of great help in detecting any of the event classes. LSTM or RNN, temporal sequence modeling essential for LBW runout and stumping decision, and transformers can be also be used. in which attention-based temporal reasoning for complex event sequences. Hybrid models such as CNN plus SVM, CNN plus random forest, CNN plus LSTM architectures improve accuracy and generalization over time. This is the key observation and research gap from the literature review that I have done. Not a single AI model can handle all cricketing events effectively. CNNs excel at spatial and visual understanding but lack temporal reasoning. Temporal models like LSTM or Transformer capture motion but are computationally heavy. Classical ML models are efficient but limited in complex scenario, but most of our studies focus on single event detection. Limitation of existing approaches with respect to the literature we have done. It is limited and it is environment specific data set, like for example, any one of the event classes like a specific boundary or a wicket. Poor generalization across stadiums and lightning condition, a high computational cost for temporal deep learning models, a lack of explainability and confidence-based outputs, real-time deployment challenges in live broadcast. This is a proposed methodology, a hybrid ensemble architecture, in which I'm going to be using deep learning frameworks, in which the first step would be importing a cricket video. After that, extracting frames from that videos as per 5 interval of seconds. After that, I'm going to do data pre-processing of the images extracted from the video in the form of resizing, normalization, or noise reduction. With with respect to that, I'm going to have parallel feature learning using deep learning techniques like ResNet, CNN, and CNN plus LSTM. For ResNet, I will be using pre-trained models for CNN, deep trained models, and CNN plus LSTM, both of the mixture of them. After that, I'm going to ensemble a fusion of model output with respect to the confusion matrix that I'm going to get as an output, and the final classification of cricket event with respect to like LBW, no ball, wicket, or run out. Conclusion and future scope. AI significantly enhances fairness, accuracy, and consistency in cricket umpiring. Literature review shows strong performance of AI models, but in fragmented and event-specific solution. The proposed hybrid ensemble framework will integrate spatial and temporal intelligence. This approach addresses key gaps in existing AI-driven DRS systems. Future scope. Real-time implementation of the proposed architecture in live match scenarios, integration with broadcast video feeds and multiple camera inputs, deployment using edge computing for low latency inference, optimization with lightweight CNN backbones and model compression, explainable AI with confidence scores to support umpire trust, in which basically I'll be using the specified deep learning framework in the proposed methodology to conclude the project. These are the references I have been used for my literature review. Thank you.
Which dataset you have used for your research work?
This is the review paper. So for the research work, I have been using data sets from the Google. It's not specified. Some videos I have been took from Kaggle, some from online, some from YouTube, some from ICC's websites.
Okay. Okay, good. Next presentation, please.
Thank you.
Yeah, thank you for presenting. I would like to call upon our next presenter, Shah Jakhon Khamdamov sir, to present his paper titled Macroeconomic Implications of CBDCs in a Digitized Global Economy. Over to you, sir.
Okay, yes, good afternoon, dear scientists. Can I start?
Yes, you can start. Your screen is visible and you're audible.
Okay, thank you so much. My topic is macroeconomic implication of SBDC in digitalized global economy. And I'm presenting from Tashkent, from Uzbekistan. And we wrote the research paper. Let me introduce this abstract part. Abstract the rise of digital currencies, particularly central banks' digital currencies, has sparked widespread interest in the potential transformation of global financial systems. This study investigates the economic impact of SPDC, comparing them to decentralized digital currencies like cryptocurrencies. A comprehensive literature review explored the key differences between SPDC and stablecoins and cryptocurrencies while examining their implications for payment systems, financial inclusion, and monetary policy for the governments. And introduction part, we try to find the research gap. So this article aims to examine the transformative role within the broader context of digitalized economy. It will explore the advantages and challenges associated with SPDC, particularly in comparison with other digital currencies. And through these analyses, the article seeks to provide comprehensive understanding and place in the future of global finance, while addressing the pressing question for surrounding their development and deployment. And as a methodology, we can say this study employs a multifaceted methodological approach, and we tried to use this estimation equation. Here we can see represents the economic outcomes, GDP growth, inflation, for monetary policy, and for country I at time t. And SPDC, it indicates the adoption of SPDC, the digital currency which I mentioned, and cryptocurrencies denotes the use of decentralized digital currencies. And XIT refers to other control variables such as monetary policy and trade openness. And E, I think we know it is the error term for econometric modeling. And also we learned some literature in this field, and we found there is a lack of empirical data on the public acceptance of SPDC is while surveys and pilot projects provide some insights, more research is needed to understand how consumers and businesses will respond to the widespread adoption of digital currencies. The literature on digital currency and SPDC has grown significantly in recent years, but several key gaps remains. While much of the research has focused on the technical and economic aspects of digital currencies, more work is needed to understand their long-term implication for monetary policy and also financial stability and for global trade, for exports and for imports. It will be also useful to improving these kind of digital currencies. And as a result, we can say our econometric analysis aimed to explore the impact of digital currencies, particularly central banks digital currencies, on key economic variables such as GDP growth, inflation, and financial inclusion. Using panel data from 25 countries over a period of 10 years, we employed a dynamic panel data model to control for potential endogeneity issues. The findings suggest significant differences between SPDC adoption and other forms of digital currencies like cryptocurrencies we know as such as Bitcoin, Ethereum, and others, and Tincoin also. Currencies that have adopted SPDC showed a positive correlation with GDP growth, with an average annual increase of 1.5 percentage in GDP compared to the pre-adoption period. And another issue encountered was multicollinearity, particularly between GDP growth and financial inclusion. The results showed that VIF test for GDP growth and financial inclusion was 2.8, and which is below the common threshold of 10, indicates that multicollinearity is not a severe problem in our model. And the next conclusion part, the central bank digital currencies have the potential to revolutionize the global financial system by enhancing payment efficiency, promoting financial inclusion, and providing central banks with new tools for managing monetary policy. However, the successful implementation of SPDC will require careful consideration of the risks and the challenges associated with their adoption. These include potential disruption to the traditional banking system, the need for adequate digital infrastructure, and concerns about privacy and public trust. Thank you for your attention. I think it's end of my presenting.
Yes, I have one question.
Okay.
Different countries have a different regulatory policies. So how it can be possible to implement this digital currency in a global financial system?
Okay, thank you for question. We recommended for governments, for central banks issuing also digital currencies. We know Bitcoin and Ethereum, other currencies. We don't know exactly who issued these currencies, and there are some problematic issues. You cannot find who transferred the money. But issuing these digital currencies by some governments, it will be legal form, and I think it will also will play a huge role for economic growth for the in this field. Thank you.
Oh, okay. Thank you.
Thank you.
Thank you for
Moving
your
towards the next
presentation,
presentation.
sir. Yes, sir. I would like to invite our next presenter, Hemlata S. Ma'am, to present her paper titled AI-powered phishing detection, improving security and protecting against cyber threats. Over to you, ma'am.
Is my slide is visible?
Yes, ma'am, your screen is visible. You can start.
Okay. So, good afternoon, everyone. Hope you are all doing well. I am Emalata, and along with my co-author Induja, I will be presenting our work on AI-powered phishing detection. So, basically, our work focuses on how AI actually can help detect phishing attacks more effectively than traditional methods. So, I will start with the problem background and motivation. So, phishing is one of the most common cyber threats today, it mainly targets users through fake emails and links. So, traditional methods like rule based systems and backlist are still widely used, but the main problem is they are static. And attackers easily bypass them using your manipulation and domain spoofing. So as a result, these systems gives high false positives and fail to detect new attacks. So now coming to existing work, earlier approaches mainly used backlist and rules, which are no longer effective. And also the machine learning models improve detection by analyzing URLs and email features. So the more recent studies use deep learning models like LSTM and BERT, which understands a context better. But still, many of these approaches lack adaptability and real world deployment. So, this gap actually motivated our research. So, based on these gaps, we defined a few objectives. First, to build an AI based phishing detection framework. Second, to compare different ML and DL models. And third, to reduce false positives. And fourth, and finally, to make the system adaptable to evolving attacks. So, these objectives guided our overall approaches. Now I will briefly explain our methodology. We use datasets like fish tank URLs and the Enron email dataset. From this dataset, we extracted URL features, metadata, and NLP-based email features. We basically evaluated models like decision tree, random forest, and also LSTM and BERT. And we proposed a hybrid LSTM random forest model combining deep learning and ensemble learning. So, yeah, with that, I will hand over to Induja, my co-author, who will explain the results and findings.
Hope I am audible.
Yeah, you are audible.
Yeah, thank you. Now I will be discussing the performance evaluation of the proposed models. In this slide, we compared different machine learning and deep learning models using a standard evaluation matrix such as accuracy, precision, recall, and F1 score. Starting with the decision tree, we achieved an accuracy of 88%, while it is simple and interruptible. Random forest perform better with accuracy of 92% as it combines multiple decision tree and reduces overfitting. And BERT achieves 94% accuracy. This improvement is due to its ability to understand context and semantic meaning in email content. Finally, our hybrid LSTM random forest model delivers the highest performance, achieving 95% accuracy along with the high precision and recall. Most importantly, this hybrid model significantly reduces false positives, which is critical in real world phishing detecting systems. The next is the key findings. In this slide, we highlight our research through a feature impact analysis. When we used only URL based features, the model achieved only 90% accuracy. This shows that URL structure alone provides useful but limited information. Using only email-based NLP features, such as text patterns and sentiments, the accuracy increased slightly to 91%. When we combine both URL and email feature, the accuracy further improved to 93%, indicating that the phishing attack often rely on both structural and linguistic deception. Finally, the full hybrid model integrating all features with advanced learning techniques achieve 95% accuracy. This clearly demonstrates that combining multiple feature types significantly enhance phishing detection performance. Next, based on our experimental result, our work makes several important contributions. First, we propose an AI-powered adaptive phishing detection system capable of identifying both known and previously unseen attacks. Second, we introduce a hybrid approach that combines deep learning with ensemble machine learning, improving robustness and accuracy. Third, our system is designed with practical feasibility in mind, making it suitable for deployment in the real world cybersecurity applications such as email filtering systems and web security platforms. Overall, our approach is more resilient against evolving phishing strategy compared to the traditional methods. To conclude our presentation, our study clearly shows that AI-based phishing detection model outperform traditional rule-based approaches. Among all evaluated models, the hybrid LSTM random forest model achieved the best result in terms of accuracy, robustness, and false positive reduction. As part of future work, we aim to integrate the system into a near real-time phishing detection environment, enable continuous learning to adapt to new phishing techniques, and improve robustness against adversarial attacks. These enhancements will further strengthen the applicability of our approach in real-world cybersecurity systems. With this, we conclude our presentation. Thank you.
No questions. We can move forward.
Okay.
Thank you.
Thank you for presenting. I would like to move on to the next presenter. Malavika Krishnakumar ma'am to present her paper titled Comparison of Parameter Estimation Techniques in Bayesian Networks. Over to you, ma'am.
Thank you. Is my screen visible?
Yes, it's visible. You can start presenting.
Okay. Good evening, everyone. Today I'll present my work, which is the comparison of parameter estimation techniques in Bayesian networks. Myself, Malaika Krishnakumar, my co-authors Ananta Krishnan, Sandra, and Dr. Gyo Gudyaha combined this work together to make this conference paper. We are from Department of Health Science Research, Amata Institute of Medical Sciences. So the background and motivation. So why a parameter estimation matters? Emphasize the practical relevance, first of all, the healthcare epidemiology and the decision support. In many application areas, in reality, especially in healthcare, we deal with missing values, hidden factors, and limited data. So important drivers of outcomes may be missing or imperfectly measured, which is still we need to model that can support decision making under uncertainty. These challenges directly affect how the patient network perform, and because everything depends on how accurately probabilities are estimated. So Bayesian networks are widely used to model uncertainty, and it can encode causal or direct relationships. And this performance of BN depends critically on the accurate conditional probability estimate. And in the real world data, it might be either incomplete, noisy, or can be influenced by a latent variable. So the core challenge for this is which parameter estimation method should we choose under different data conditions. So a brief overview of what is a Bayesian network. So a Bayesian network is a directed acyclic graph. It has a node which represents the random variables and the directed edges which represent the conditional independence. And they are populous because they explicitly model uncertainty in structured and interpretable way, which is very important in clinical decision support, where black box predictions are often not acceptable. So Bayesian networks belong to a larger family, which is known as probabilistic graphical models. And the key idea is that instead of storing a massive joint probability table, we exploit the conditional independence to represent the system compactly. So each variable in a Bayesian network depends on its parent variables, and this factorization is what allows the Bayesian network to scale to a higher dimensional problem while remaining interpretable. So the main focus of this study is on a parameter estimation. So basically learning a Bayesian network involves two tasks. First is structure learning and the second one is parameter estimation. In this work, we assume that the structure is already known based on our expert knowledge, and we focus entirely on parameter estimation. We deliberately isolate the parameter estimation problem. And this helps us to compare the estimation techniques cleanly without any confounding factors from the structure learning. Here we are basically using four estimation approach: maximum likelihood estimation, Bayesian estimation, expectation maximization, Monte Carlo methods. And the key comparison is between the frequentist and Bayesian approaches under latent variable scenarios. So what is maximum likelihood estimation? It is a very default approach. It is very simple and efficient. In discrete Bayesian networks, it essentially counts how often an event occur given their parent configuration. Like it estimates the probabilities purely based observed data, essentially by using relative frequency. And this works very well with the large and complete data set, but it struggles when the data are sparse or incomplete, which is really common in real applications. And the limitations are the zero probability problem, where the equation becomes zero and the probability becomes zero. That is zero probability equation, and cannot handle the missing data directly, and it is very sensitive to small samples. Next is Bayesian parameter estimation. In Bayesian parameter estimation, when you have a discrete Bayesian network, we use Dirichlet prior on conditional probability parameters. And here we have an advantage that we can update the prior using the observed data. And then we try to get the posterior distribution. And the advantages is that here there is no zero probability problem. And it incorporates the prior knowledge, and it is very robust for small sample sizes. And the assumptions is that they fully assume that the data is completely observed, and they cannot directly handle latent variables. So what is dealing with latent variables? The latent variable problem is not just a technical nuisance, but they are reality in observational and clinical research. So many important variables cannot be directly observed. Ignoring them can seriously bias parameter estimates, such as bias and incorrect causal interpretation. So when latent variables are present, direct likelihood maximization becomes infeasible. To address this, we have two solutions: either to combine MLE plus EM algorithm, which is an iterative estimation using expected counts, or either combine Bayesian plus Monte Carlo, which is approximate posterior via sampling method. So EM algorithm, it's a frequentist solution. So it is an iterative procedure. In the E step, the algorithm computes expected values for the missing or latent data given the current parameter estimates. And in the M step, they update using these expected values. An important property of this is that the likelihood never decreases across the iterations. And a limitation is that they may converge to a local optimum rather than a global optimum, and is sensitive to initialization. Next is Monte Carlo methods, which is the Bayesian solution. In this Bayesian network, latent variables are handled using Monte Carlo sampling methods such as Markov chain Monte Carlo. These methods approximate posterior distribution by drawing samples from them. This method are flexible and can handle complex model when we have a latent variable. And the main trade-off that is usually seen here is the computational cost, as these methods are typically more expensive than the expectation maximization. So we have used a simulation design. So why simulation? To compare these methods fairly, we use simulation studies where the ground truth is known, and it allows us to isolate the effect of the estimation without having any confounding effect from an unknown real-world mechanism. And here we consider two scenarios: when the latent variable is a confounder and when latent variable is a mediator. So the first scenario is latent confounder. In this scenario, we have a classical confounding where an unobserved factor influences both the predictors and the outcomes. And this scenario mimics the observational studies where an unmeasured factor influences both the exposure and outcome, creating a confounding bias. So here the goal is basically to estimate effect of latent variable on outcome. And the scenario 2 is a latent mediator. The latent variable is a mediator rather than a confounder. So this allows us to test whether estimation methods behave differently under different causal roles. And by considering both confounder and mediator roles, we test the robustness across different causal structures. So here is the structure, basic structure. Here the influence of the predictors x1 up to xm on dependent variables y1 to ym is mediated by an unobserved variable z. So our simulation design, these choices reflect realistic study sizes and effect magnitudes commonly seen in applied research. And by systematically varying these parameters, we can assess the robustness and stability across a wide range of realistic settings. So here we have 1,000 simulation replicates, and we have variable sample sizes of 500, 1,000, and 2,000. And we have provided an effect sizes odds ratio of 1.5, 2, and 3. And we have predictors 5 and 10. And we compare the estimators in two ways: for frequentist MLE with the EM, and for Bayesian method, we have Bayesian estimation with Monte Carlo method. And the evaluation matrix is provided by median absolute error and median absolute deviation. So these are the results. So we can see that overall performance is very similar. The Bayesian approach is slightly better when we have a small sample size, and MLE EM is slightly better when we have a larger sample size. So here we can see N is the sample size. So for MLE approach, we have a better performance when we have a sample size of N equal to 2,000. And for Bayesian approach, we have a better performance when we have a small sample size. So now consistent influence of the number of predictors or effect size. So neither approach dominates universally. Differences are modest and mainly driven by the sample size. So the interpretation and practical implications. So why do these results tell us? Like, what do this result tells us? So there is no universally superior estimator. The method of the choice of estimation should depend on the sample size, presence of the latent variable, and computational resources. So when we are handling uncertainty, it is better to use a Bayesian method. And for efficiency in scalable methods, you can go for frequentist methods. So rather than defaulting to one method, analysts should choose the estimator that best matches for the data and constraints. So the conclusion and take-home message is that EM-based MLE and MC-based Bayesian estimation perform comparably, and these methods are more robust with limited data, and frequentist methods gain advantage when we have a larger data set and it supports context-dependent estimator selection. So both approaches are valid, and Bayesian methods are safer with limited data, and frequentist methods are efficient with large data. Understanding their trade-off will enable us to have a better modeling. In summary, both approaches have their place, and informed method selection leads to a better Bayesian network modeling. And to conclude, both method frameworks are valuable. Understanding their strengths and limitations allow us to apply Bayesian networks more efficiently in real data problems. Thank you, and I'm happy to take questions.
My question is that what is the limitation of Monte Carlo method?
The Monte Carlo methods is having the limitation that it has a variance sensitive. So when poor sampling strategies or high dimensional space can cause a very high estimator variance. That is an important limitation of Monte Carlo method.
Because you have applied this method when you have unobserved variables.
Yes. And
So
Monte Carlo method is also used for like it has a limitation when we have a latent variables also. So we are trying to compare with the Monte Carlo estimation with the other models and see like what will be the better for a unobserved variable sample size.
okay, fine. Thank you.
Thank you.
Thank you for the presentation. I would now like to call upon our next presenter, Kanuso Manikanta Sai sir, to present his paper titled Drishti, a low-cost wearable visual navigation assistant using ESP32, CAM, and BLE-based smartphone TTS. Over to you, sir.
Hello, am I audible to you? Hello,
Hello, sir, you are audible.
yeah. Is my screen visible to you?
Yes, the screen is visible. You can start presenting.
So, good afternoon to everyone. I am Manikanta Sai from Amrita Vishwavidyapitham, Bangalore. Today, I am here to present our work titled Dristi, a low-cost variable visual navigation assistance using ESP32 camera and BLE-based smartphone TTS. This work focuses on helping visually impaired people more safely and independently using a lightweight and affordable wearable devices. Now, let's start with the motivation behind this work. For the visible impaired person, moving independently is very challenging. Most of the existing assisting devices are bulk and uncomfortable, very expensive, and power hunger, and rely on unrely on low light conditions. Also, many systems do not give real-time feedback, which is very important for safe navigations. So, this raised an important question: can we design a system that is affordable, light, weight, and gives a real-time guidance? This question is the motivation for us to build Dristi. Based on this motivation, our problem statement is as follows. We aimed a sorry, we aim to design a low-cost spectacles mounted assistance device that detects the object in real time, provides the fast haptic feedback, avoids heavy computation and variables on the variable, and remain comfort and social acceptance. In simple words, to summarize, a smart system that feels natural and where too easy to use. So, while coming to the literature survey, to summarize all, many of the studies showed that head-mounted devices improve awareness and confidence. Some systems use ultrasonic sensors, which are low cost but lack in environmental understandings. Other works focus on vision-based systems, but they were expensive, power insensitive, and not suitable for lightweight variables. So each approach has the strengths, but clear limitations also. However, we observed that many systems depend heavily on smartphones, BLE latency, effective real-time performance. and very few systems focus on low cost implementation. So, based on this, uh, to summarize our related work, vision-based system for high accuracy uh, but high cost, ultrasonic sensors, low cost but poor context, smartphone-based systems, flexible but high latency. So there is no single solution that balances the cost, comfort, and speed and reliability for the users. So, based on our survey, we have found few literature research gaps. The main research gap which we have found is high cost and bulky designs, which are difficult for the users, difficult in real-time vision, and also ultrasonic fusion, limited feedback options, uh, and poor user comforts. To address these gaps, we propose the Project 3. Now, coming to the key contributions of our works, the hybrid variable smartphone. The hybrid variable smartphone architectures, lightweight process on the variable smartphone uses for text to speech. Here we will be having an end-to-end system where the latency is less than 30 milliseconds. And since we are using both the ultrasonic and vision for the haptic feedback, it is multi-modeling sensing object. And now coming to the system overview, it is a variable module with ESP32 camera and ultrasonic sensor with haptic vibration motor. The smartphone handles the high level processing, and Bluetooth low energy is used for communication between the mobile device and the ESP ESP32 microcontroller. While coming to the pipeline, first the microcontroller is sensing the object, and it with the help of the sensor and also its camera. And after that, the pre-processing will be happening, and based on that, the fusion of both, and based on that, we will get the feedback of the haptics. Now, coming to the hardware components which we have used, we have used ESP32 cam microcontroller, ultrasonic sensor, haptic feed, a coin-sized haptic feedback vibrator, a power management module, and a spectacle frame. We can see in the image, this is the model which we have prepared for our project. Here is the processing pipeline, how it works. The images are captured at a specific resolution. The edge detection and region of interest extractions are applied. Ultrasonic measures the obstacle distances, and the sensor fusion completes the obstacle severity, as it is too close or it is too far, etc. The feedback will be given based on the vibration or haptic feedback. The pipeline ensures the real-time performance of the model. Now coming to the variable design and calibration, the device is mounted on a spectacle of natural gas alignment, which ensures the balanced weight distribution, adjusting vibration intensity, and accurate distance calculation on it. These designs support continuous real-world usage without discomforts and all. Now coming to the results and analysis, we have tested our Drishti in two different scenarios. The first one is fixed distance detection, and second one is low light navigation. Uh, In the fixed distance detection, the static obstacle was placed around between 0.5 meters to 2 meters, and different head orientations are allowed. Ultrasonic accuracy was very high, and we got the communication or the movement to our device within a latency of less than 30 milliseconds. And while coming to the low light navigation, we have evaluated in dim and uh, dark environment. The LED which is present in the ESP32 microcontroller had uh, improves the image visibility, and ultrasonic sensor was unaffected both in the presence of light and uh, in the absence of light. It worked equally, and Yeah. Now coming to the performance summary, overall performance highlights include the real-time multimodal feedback, robust obstacle detection, low power consumption, high responsiveness, and improve users' confidence. These results validate the effectiveness of our approach. In the future, we plan to test the device in the outdoor and uneven terrains. As of now, we have uh, worked in the laboratory and also open grounds with few obstacles. Mm, conduct a long-time user survey, improve the sensor fusion integration, and also further enhancement usability and safety. Now, coming to the conclusion, Drishti is a low-cost variable navigation assistance, provides real-time obstacle detection by the haptic feedbacks, etc., uses effective multimodular feedback, and offers the scalable solution from visually impaired users. We believe Drishti can make independent mobility safer and more accessible. Yeah, thank you.
My question is that what is the approximate cost which you have calculated for this device?
Uh, it's around 1400, sir.
1400 means you have mentioned that it is a low cost device, so you have done the comparison with the existing one, right?
Yes, sir.
Okay, is it a funded project or independent project?
What, sir?
It is a funded project by some
No,
agencies.
sir. It is an independent project which we have did as a part of our course.
Okay, fine. Thank you.
Yeah. Thank you.
Thank you for presenting. Now I would like to call upon our next presenter, Ruchit M. Sir, to present his paper titled PalmNet AI, Automated Palm Design Detection Using AI and Organic Management. Over to you, sir.
Yes, ma'am. Am I audible?
Yes, you're audible and I can see the screen. You can now start presenting.
Okay, thank you. Uh, our project is about a crop detection, which is majorly concentrated on farmers' welfare. In this AI-powered organic, we are getting so many diseases in crops, majorly in aracanut and coconut. We have concentrated on it. So, as here I mentioned, we are getting every plant detected in several apps, which can they will be giving some predictions like they can detect every disease, but it can't be able to access with an AI, or some apps can access AI but not give the prediction. We have merged both the we have merged both AI and giving the prediction in organic way, which can get more yield. Uh, then problem statement is agriculture, small scale organic timelines, and reducing yields. It's an economic loss nowadays. So we have taken a major step to give the farmers in organic predictions, which can support every disease in an organic way, and as well as in an ancient times they were not using any chemical fertilizers or something. They were using home remedies like some cow dungs, neem oil, etc. So we have concentrated on it. Coming to literature survey, we have taken titles from authors from 2025, 24, and 23 also. They have, according to them,
they have driven many eligibility live monitorings, and they have improved many things. So their cost was very high. We have introduced in some which can be used, and data is also not risky to compare, which is compared to other apps which are present in this uh, platform right now. So we are basically concentrating on offline detections, which can help every farmer in the world to take ensure of this app, and make their diseases and some problems of their crops to get more yield in an organic way. Existing, as I said, there are many for apps where they have giving chemical treatment which are not suitable for organic farming, and small scale farmers can't what can I say, can't get afford that much amount to get some solutions for that good yield of crops. So we have taken a good decision like giving offline, user friendly, eco friendly, and organic way. Coming to proposed system, uh, in our app there is high accuracy of AI detections, faster response time, and promotes organic farming. This is the major concept which we have developed for the farmers, and to reduce the increase of diseases or illnesses. It's user friendly, which can be used by any farmers, and it will be available in their suitable regional languages. Objectives, it will be early detecting, then organic specifier solutions, real-time monitoring, which can be taken directly from the camera and given to the app to detect the leaf which it is diseased, and to get the cure. Then this is the system architecture which our app is concentrated on. Then system design in input of captured for analysis, and it will reduces some blur images. It will retake the image, and it will for pre-processing it will be smoothing and filtering the conversation, then classify images as healthy and diseased. If we give any person's image or a non-leaf image, it will not detect. It will give it's not a image of leaf. Retake the picture. In disease plant, it will take the analysis of leaf sensor AI and smart agri advisor for the treatment. Then the final step of the treatment, it will show every disease solutions with to the farmers with the organic way. This is the data flow diagram. The farmers can show the plant image to our system. It will detect the plant data. It will send which it will be sent to the plant database, and if it's healthy, it will directly go to the symptoms. It's healthy. If not, it will go to the system, and it will decide it's diseased. So like this, it will take some times how much leaf diseased is. And system models image, it's an yeah, in palm trees, we will take a leaf of images through app, then it will be processed according to the RBG, RGBs to scale down to gray, as shown in this steps and techniques. Then algorithm which is used for masking k-means cluster. Techniques is hologram equations and color holograms. Next is system model. Uh, the symptoms of matches the symptoms which is matches to the leaf diseased. So it will give a particular disease name, and it will provide a particular solution according to the leaf. Input specifications, image data, environmental data according to temperature, humidity, and soil moisture. Metadata has we specified has palm trees. So historical records as per the organic treatment are from ages which are mainly it will give a good yield, and it will be costing around 100 to 200 rupees per such things. So output sequences are like this. Disease detections are diseases like brown spots, red palm leaves, and yeah, and some leaf biting insects. Some are occurring like this. So organic treatment, which is recommended, it is natural remedies like neem oil, etc., etc. Then crop health report summary has it will get into your phone as a PDF. So like this, we have designed a small app which will cost around 15 to 20 MB. UML, according to this UML, the farmer will upload a plant image and with the diagnosis and with the treatment advice. What image they have inserted, the advice will be given according to that. Then classification, activity diagram. This is the segment of the app which is clearly showing the uploading of image, segmenting the image, extracting the features. If it is not diseased, it will directly advise the treatment. If it is diseased, it will analyze the symptoms and give the particular disease treatment for on the app.
Sir, you've reached the 9 minutes mark. Can you please speed up your presentation?
Yes, ma'am. I'm at the end.
Yeah, thank you.
Okay. Hardware requirements is a smartphone for testing and a processor. Any devices like Snapdragon now coming. Its RAM is like around 4 GB. We have created according to that, and software requirements we have used Python, ONNX module, and PyTorch module for the data collaboration with Android Studio and Powerbase. Here is the design result of analysis which we have done according to them. Here we can see a leaf with no disease, so it is given disease healthy, cure is not required, and prevention maintain healthy crop. This is the Gantt chart which has we have done. Conclusion: early detection and real time. What we have what the problems faced by the farmers and limited time for impact should be given to the farmers earlier to get the more yield from this app. Thank you. Any questions, sir?
No questions.
Thank you, sir.
Thank you for presenting. Now, I would like to call our last presenter of the session, Anisha Kaur ma'am, to present her paper titled Sarcasm Detection with Agentic AI. Over to you, ma'am.
Am I audible?
Yes, ma'am, you're audible.
Okay. Is it visible right there?
Yes, the screen is visible and you can start presenting.
Okay. So, uh, good afternoon, everyone. I'm Anisha Kaur, and I'm a student of MIT ADT Pune. Currently, I'm pursuing my MTech in computer science engineering. So, today I'm here to present the sarcasm detection with agentic AI topic. So, at first, I would like to give a brief. This characteristic makes sarcasm extremely challenging during neural processing system. Traditional NLP models rely heavily on surface level sentiment, lexical and patterns or statistical correlation. However, sarcasm depends on deeper factors such as context, user, intent, and prior conversation. So, in the introduction part, I have just mentioned that sarcasm detection is a critical challenge in NLP, and it mainly focuses on sarcasm detection in social media conversations, use of agentic AI and multi-agent reasoning, and incorporation of contextual and behavioral understanding, and some of the improved accuracies and explainability over traditional models. So in this slide, I have mentioned some of the challenges that sarcasm detection often faces. The sarcasm often conveys meaning the opposite to the literal sentiment and making detection quite difficult. And it has a strong dependency on context, user behavior, and also paradigmatic intent. Lack of adaptability and also explainability in traditional NLP models. Then this is the motivation and the problem statement. Motivation is the growing use of sarcasm in social media. We can see that causes frequent misinterpretations and also the by sentiment analysis. Accurate sarcasm detection is essential to improve the reliability of opinion mining chatbots and also effect ever of the NLP applications. The increasing sarcasm uses in online communication, errors in sentiment analysis, and also opinion mining, and need for context ever and intent based in understanding, demand for explainable and reliable AI system. And the core problem we address is the existing sarcasm detection system are largely statistic or text centric that they fail to adapt to the evolving language patterns, user behavior, and contextual shifts as well. Moreover, most of the models provide predictions without clear explanations, making them unsuitable for sensitive or real world decisions making systems. This gap motivates the new needs for more adaptive and reasoning driven explainable approaches. In this slide, I have just mentioned some of the existing review of the existing sarcasm detection methods, where the sarcasm detection research has evolved through multiple phases. Early approaches were rule based, relying on lexical cues such as sentiment contraction and punctuations and also the hashtags. While these methods were interpretable, they were brittle and failed to generalize across various domains. Later, the traditional machine learning models, such as support vector machines and also some of the naive base, were introduced using the handcrafted features. This improved the performance slightly, but require extensive feature in engineering. So, with the rise of the deep learning and CNN and also LSTMs enable better representation and learning. More recently, the transformer-based model like BERT and Robert significantly improve the contextual understanding. And in this slide, I have mentioned the proposed agentic framework, AI framework. The proposed framework introduces an agentic artificial intelligence, according to which the model sarcasm detection is a collaborative reasoning task, and also the multiple autonomous agents analyze the linguistic cues and also the contextual informations, and sometimes also the user behavior in order to produce the adaptive and explainable sarcasm predictions. The agentic collaboration, it actually enables the human-like reasoning and also the adaptability, explainability, which are missing in the traditional models. This is the literature survey. So here comes the system architecture and also the methodology. The system flows into a multiple stage pipeline designed to reflect the human interpretable behavior. First, the social media text is collected, then it is pre-processed, then the noise removal is done, then comes the tokenization phase. Then come the lemmonization phase and also the synthetic tagging, along with the raw text and auxiliary cues such as emojis, hashtag, and punctuation, emphasis, and metadata are preserved. The contextual embedding are methodology. This is the methodology where the data collection, pre-processing, feature extraction, and model development and evaluation. Then comes the deployment phase. And the contextual embeddings are generated using the transformer encoders such as BERT or Robert. These embeddings are divided into linguistic as well as some of the behavioral representations. The agentic AI model then processes these representations using multiple reasoning agents. A coordinator agent aggregate the insight and also resolve the conflicts. The reinforcement learning continuously updates agents' policies based on feedback, allowing the system to adapt to evolving sarcasm styles and language trends. This is the block diagram. This is another block diagram where the data acquisition and pre-processing stage is done. Then come the contextual embedding, where under that we can see the linguistic features and also behavioral features. Then comes the agentic AI model, suppose the actor. Then comes the coordinator, and then simply the sarcasm detection is done. This is the mathematical formulation slide, where the mathematically sarcasm detection is formulated as a probabilistic classification task. We define a sarcasm probability scores that depend on contextual behavior, emotional as well as the syntactic or semantic features. These features are combined through adaptive scoring of functions. The weight of these functions are optimized using the reinforcement learning, and which is based on the classification performance. We can additionally say that the user state representation and behavioral prosperity models are coordinated to capture long-term user tendencies. A regularized loss function ensures a balance between accuracy and also behavioral consistency. These are some of the research challenges. Despite its advantages, sarcasm detection faced some challenges related to the data ambiguity, scalability, and also the personalization. Addressing these issues is essential for real world development. Sometimes it can be noisy and ambiguous social media data, personalization versus generalization trade off, and high computational complexity, and also the ethical and deployment constraint. So we have reached the conclusion and future work phase. This work represents agentic AI-based framework that enhances the sarcasm detection through contextual reasoning and also behavioral modeling and adaptive learning. This approach actually improves both accuracy and also interpretability, which is effective in handling the implicit and contextual sarcasm, and also improve explainability through agent reasoning, and also adaptive learning using reinforcement learning. Future scope, we can say the multilingual and real-time development. As a future work, we actually aim to extend the framework to multilingual and cross-cultural sarcasm detection, incorporating to the multimodal signals such as image and also the emojis, and also deploy the system in real-time, large-scale social media environments. Thank you. Any questions?
Yes. What is the limitation of your work?
Sir?
What is limitation of this research work?
Actually, the limitation for time being is as I mentioned, we'll be working on the image and also the emojis. Sometimes our sarcasm detection system with agentic AI is not able to capture the emojis. So we'll be working hard on the on that part.
Okay, okay, thank you.
Thank you so much.
Thank you for presenting. So since all our presentations are done, I would like to move towards the closing remarks. I would like to sincerely thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. And we'll be happy to have you in the next year as well. Now, all the presenters would be getting their digital certificates through email within 2 days, and the publication will be live within 7 to 8 months. Kindly cooperate with the team of SMARTCOM 2026. I would like to thank our session chair, Dr. Vinodra Kumar, for chairing the session. Here is a token of appreciation to the chair on behalf of Team SMARTCOM 2026 and Global Knowledge Research Foundation and partners. Thank you, sir. Thank you for your
Thank you
valuable
so much.
presence.
Thank you.
Yes, thank you, sir. Before finally ending this session, I would kindly request everyone to switch on their cameras to take a quick snapshot of the virtual conference. Can everyone please on their cameras? Yeah, thank you. Just a second. Yes, I've taken the snapshot. Now you all may leave the meeting. I would like to end the session. Stay safe and take care. Thank you.